Good morning, I'm on site here at electronica 2024 and today I'm pleased to be joined by Dave Schneider, who is the Global Vice President for Electronics Materials Solutions Division at 3M. And today we're going to be talking about 3M material science solutions helping enable the future of AI. So Dave, thanks very much for joining us today. Why don't you give us a brief introduction to yourself?
Sure, thanks so much for having me, I really appreciate it. I've been fortunate to be with 3M for a little over 30 years. And 3M is a wonderful company. I've had a chance to work in many different businesses, ranging from telecommunications to our electrical markets, separation and purification, automotive aftermarkets, and where I'm currently our electronics market. I'm currently the Vice President, as you said, of our electronics materials. I most like electronics because this is the third time I've been in this business. I've been mostly in electronics and fiber optics most of my career, but really very fortunate to be working with 3M and have such a great company to have a lot of technology to work with.
Fantastic. And for those who perhaps aren't as familiar with 3M as we are, can you give us a bit of an introduction to the company?
Yeah, sure. 3M is very much a technology diversification company. We're a very large conglomerate. We started out in 1902, so a very long-standing company. We're a material science company at its core. With about 60,000 employees, we're focused on driving new solutions that are in many things that people aren't really aware of because it's inside a lot of devices. We operate in 3 different business units. Most people know us for our consumer products, so like Post-it notes, Scotch tape, that's our consumer business. Our other business is our safety and industrial business. We're very focused on worker safety. So during COVID, our N95 respirators were very important. We do a lot of fall protection products. We have an abrasives division in that group also, so we do abrasives from polishing implants for knees, hips, to abrasives for making airplanes and cars to making golf clubs. And then we have a lot of things in our industrial adhesives in that business group. Our third business group is where we are, is our transportation electronics business. And that's really where we're focused on working with end users and end OEMs. And that's where a lot of our products are inside devices that people don't even know. So for example, our multi-layer films or optically clear adhesives are in most smartphones around the industry. We do a lot of things for automotive in electrical vehicles, for battery, for safety and protection and in performance improvements in the batteries. We also do a lot of things in automotive for removing weight. So as you look for more efficiencies and lighter weight materials to replace rivets and screws, we do a lot of adhesives. In our group, our electronics materials group, we're very focused on semiconductor manufacturing processes, similar to consumer electronics, and then we also do a lot in data centers and factory automation areas.
Fantastic. I didn't know the portfolio was so diverse, so thank you.
Well, I'll give you a fun fact. You're never more than 3 meters away from a 3M solution.
Excellent. That's a good fact. Okay, so tell us, how does 3M approach material science with AI applications in mind? I'm thinking particularly for data processing and storage requirements.
Sure. With 3M being a material science company, we like to think of our capabilities as a periodic table. We have 49 core technologies that we focus on. And even when we focus on an AI application, it's not much different than we focus on other solutions that we need to develop. We want to first understand what's the customer need, what's the problem we're trying to solve, or what does the industry need. And you think about for data storage and logic and things like that, one of the areas we focused on is taking our material science. In the semiconductor area is a good example where we provide solutions into chemical mechanical planarization. And as we get down into the advanced nodes from 5 nanometer, 3 nanometer, 2 nanometer, and going into the angstrom, the polishing of a wafer becomes extremely critical for getting the GPU to have that performance. And we've taken our micro-replication technologies, our abrasive technologies, our coating technologies, and put them together to make some new pad conditionings and new pads to allow those processing in the wafers at the very fine features they have to get down to.
Fantastic. And could you share some examples of specific material innovations from 3M that have been pivotal for sort of AI hardware development?
Yeah, actually I'll share 2 and I'll give you maybe a couple examples. I'll share one that we've already had in the market, we've been expanding upon it. It's our flat twin axial cable for high speed. And what we've developed is a ribbon cable that is flat and it's flexible and you can bend it and kink it. So what this allows, so when you hook up a PCI Express inside a server or you do an external cable from server to server, because of the high signal integrity capability, but the ability to bend and flex it, you can now route the cable inside the server to allow airflow. So as you get so much more heat in the server, you need to have better airflow to cool everything, and our cable allows that. But also when you do the racks and you go from server to server within a rack, there's so much cable now in there that you need to be able to have more space. And because our cable is very flexible, you can bend it around corners and really force it into the edge of the rack to make more cable in a smaller space, so the space savings. The other technology I'm actually really excited about, I'll show you a couple examples here. We've taken our science around light management, optically clear materials, microreplication. We created a new expanded beam optical ferrule. So the traditional ferrule in the industry is a MTP. It's a physical contact ferrule. And we developed a very small optical ferrule. Here's a 16 fiber expanded beam optical ferrule, and it goes into a cable assembly. And what the benefit of this is, when you connect this on a server faceplate or into a switch, it is now expands the beam optically, so there's not a physical contact from ferrule to ferrule. There's actually a gap, and that gap allows you to be able to plug the ferrule in and not ever have physical contact. The problem when you hook up an AI data center and you hook up all the cables and the servers into the racks, you end up having to test every single cable, because when you have physical contact, you usually get dust on it, debris, you have failures. You have to pull the cable back out, test it, clean it, put it back in and test it again. Our cables allow all that to go away. So when you plug it in, it works the first time, there's never a dust problem. And it also allows you to take 144 fibers and put it into one connector. And we've developed in such a way it has low insertion force, so you can plug in one cable assembly into from a drop cable into a back of a switch or into a rack with 144 fibers with one connector, just like plugging it into a wall outlet with your power cord. Very simple, low insertion force, and one cable connection, you're done. That's just being launched now in mass, and we're very excited about what that'll do for the next generation of data centers and AI servers.
Yeah, some great examples there, and thank you for bringing them along. And I think, AI hardware often faces challenges around heat dissipation and power efficiency. So how do your material science, how do they address these issues, and what unique solutions have you developed?
As I mentioned with this flat ribbon cable, we've had customers actually test this in their servers, and because we can route it around different components, allow better airflow, they can actually get it up to a 3 degrees centigrade reduction in heat of the server. And that becomes really important as you do airflow. You can get maximum operating temperature of the GPU and improve everything with that. But we also look at, as we look at AI going into phones, into tablets, that heat becomes critical, but there's also, beyond the heat aspect of it, it creates other noises with all the AI, with all the different wavelengths of light you have, or the Bluetooth, or the different frequencies. So we've also focused on not just the heat aspect of it, but we looked at the signal integrity part of it that happens at the same time. And we can customize our EMI shielding materials or our absorbing materials to help improve the signal integrity of the overall device inside the system.
And following on from that, I think another trend is miniaturization, and that's becoming crucial as AI technology advances. So how do you support this trend with adaptable materials for compact, high-performance AI devices?
Yeah, it's one of the things that, going back to when I mentioned we were a material science company, is our company is always looking at how to advance our current state of products. So there's always a continuous evolution of improving solutions. But one thing we do a little bit differently, how we manage our material science as a corporation, is most companies have a business unit or a division that owns certain technology, and a different business or division owns different technologies. 3M has, the company owns those core technologies, so everybody in the company has access to those core technologies. And when we look at solving a problem, we can pull from any area to combine technologies to create new solutions. So as things get into miniaturization, we can pull materials from other divisions that are maybe used it for something else that have already proven success to help apply it. So one area I mentioned is in our semiconductor area, miniaturization is always happening in manufacturing of chips. As you get into narrower line spacing, you get into higher stacking of the layers of the chip. We're pulling in the materials that help actually allow for hybrid bonding. So hybrid bonding requires a very perfect planarization as you start stacking chips on die. And that planarization is critical, but it also requires special materials and coatings on your conditioners to make sure you can enable that to happen. We pull in materials in our twin axial cable, there's a dielectric inside of here. The dielectric is what creates the signal integrity, especially after you kink it. So as you look at higher frequencies, as you get up to 800 gig or 1.6 terabytes, we're constantly improving our dielectrics to allow that, to make sure you can get that same signal integrity at the higher data rates over the distance you need to get to.
So how do you balance performance and longevity with the development of new materials for AI hardware?
Yeah, that's not easy, is it?
No.
One of the things we always do when we develop a new product, everything goes through very rigorous testing to ensure it meets the performance, but we also go through accelerated aging. And the good thing about accelerated aging for us is we want to understand the molecular level of the materials, what's happening over the accelerated aging, to understand what do we need to modify of the material to make sure it meets the performance, meets the lifetime of what the customer needs, and can we do that in a short enough period to actually meet the time to market and the window that the customers need the product in. So it's a kind of an iterative process of how we do that material understanding, and along with accelerated aging, with the development, working jointly with our customers.
Mm-hmm. And following on from that, I think a big topic for engineers at the moment is sustainability. So how do your products help your customers meet sustainability goals?
Yeah, sustainability is a very key focus for 3M as a corporation, as most corporations are looking at how do we improve what we provide to our customers, how do we impact the planet. Where we start is actually with every new product we develop and we introduce, it's a requirement of the corporation that that product has to have a sustainability commitment. And it could be we're using recycled materials, so we're actually putting less material into the environment. We could be using bio-based materials. We could be using something that provides lower carbon footprint. There's a lot of different ways we look at it, but every product has to have a sustainability impact and improvement. One of the areas I'm really excited about is what we've gotten into is, you probably hear about the Right to Repair Act for electronics. It's happening in Europe, happening in many parts of the US. We developed a new adhesive tape for assembling electronic components that is debondable on demand. So if you get a cell phone that you want to repair or you want to recycle, typically you recycled, it was hard to take things apart, to put the battery here, put the glass here, put the metal someplace else. Our adhesive we've developed is by adding either a localized heat or localized current, you can actually change the molecular structure of that adhesive temporarily. And it debonds, so now you can actually cleanly take things apart and either recycle them, or because it's temporary debonding, you can repair it and actually bond it back together without using adhesive. Mm-hmm. So it's a real step forward of how we enable our end users and the customers to be able to either recycle or repair things without adding more material to it.
Fantastic. And I'm interested to hear what you see as the next big challenge for material science, especially in AI, and how is 3M preparing to address it?
Yeah. I think about, I believe it comes down to power efficiency across AI. And, the GPUs are going to be up to 1,000 watts per GPU. It's using so much power. To get to that, you have to create a chip that actually consumes less power, and that means it's going to have a finer line width. It's going to have better efficiencies in how it was manufactured. You have to be able to cool some of that, but then you have to figure out how do you just eliminate the need for the power. So we're doing a couple things for development areas. We believe our EBO optical ferrule will help reduce the number of connections you need. So we can now take and replace some of the active optical cables or the active electric cables and start using pure optics, which will require less power to run. But if you start looking into the design of the architecture of the system, typically you have the electrical signal come from the GPU. It goes to an electrical to optical conversion at the faceplate, and then you have an AOC or electric cable that connects into it. That takes a lot of power. Yeah. You start moving that optical connection instead of the faceplate back to the chip. So then you start removing some of those E to O and O to E conversions. And we're working on taking our EBO optical ferrule and working with customers for the future and say, how do you make a separable interconnect at the chip? So now you start reducing the number of connections, but you also reduce the amount of heat required. We're also working on materials to help reduce the actually improve the generation of heat removal from the chips. New materials, we got a lot of work to do in that. A lot of companies are working on it, but we believe we have the right materials to apply special fillers and other things to our heat dissipated materials to help remove heat faster and more efficiently.
Mm-hmm. And following on from that and looking ahead then, what would you say are some of the company's priorities for advancing AI hardware materials over the next 5 years?
Yeah. Our two of our biggest priorities is, as the data centers are growing very fast, we want to enable the connectivity of the data center in a more efficient way. So we're very focused on driving optical connectivity, not just the way it is today, but how the future looks is where it gets more co-packaged optics and silicon photonics. At the same time, there's a transition period where as things go to higher data rates, we're continuing to drive higher data rates with the copper to help that transition as customers can't go all optical right away. And then we're continuing to look at, as the AI gets into the devices, how do we enable the devices too? There's so much happening inside the device as you get into your phone and get into the tablets of more AI functionality. There's a lot of new materials required in those devices. So we're very focused on the consumer electronics side of it, but also on the data center side of it to provide the right solutions.
Okay, and finally then, Dave, can you tell us a little bit about 3M's partnership with DigiKey and how you see that benefiting your customers?
DigiKey is an amazing company. We've been working with them, I think, 37 years now. We started with them with mainly just our copper interconnect portfolio at the very beginning, and working with them over the years, they have access to almost every 3M product now. And they're so unique in how they get to customers, how they market to customers. Their logistics are by far the best in the industry, and our customers feel the benefit of that. They get products quick, they get it on time, they always get it consistently, which is a big benefit. And then just having, being two Minnesota companies, it's just amazing how similarity our thought processes are, our cultures, and working together. It's a really joy to work with them, and we've had a really good relationship, and we want to keep taking it to the next level.
Excellent, so do we. So thank you very much for your time and for your insights. It's been a real pleasure speaking with you, and enjoy the rest of the show.
Thank you.
Thank you.